Good morning, dear students. Let us have a look at this question from JEE Advanced 2020. This question is from the Thermodynamics chapter. So let us first analyze the question. As shown schematically in the figure, two vessels contain water solutions at temperature T of potassium permanganate of different concentrations N1 and N2. So we can see these two vessels here. They contain water solutions of potassium permanganate at temperature T. These two vessels have different concentrations of potassium permanganate. This has a concentration N1 and this has a concentration N2. So N1 molecules per unit volume and N2 molecules per unit volume. It is given that N1 is greater than N2, which means the concentration of K1O4 in this vessel is greater than the concentration of K1O4 in this vessel. So you can observe here that the solution here is darker and solution here is lighter in color. It is also given that delta N, which is equal to N1 minus N2. So delta N is the difference in the concentration. This is much lesser than N1. So what he means by this is the difference in concentration is very less. They both are almost of the same concentration and the concentration of this is slightly more than this solution. They are connected by a tube of small length L and cross-sectional area S. So we can see that these two vessels here are connected by a tube of length L and cross-sectional area S. I have drawn a bigger tube here so that the visualization is much easier, but he has mentioned that it is a tube of small length. Okay, so this L is very small. K1O4 starts to diffuse from the left to the right vessel through the tube. So we can see here that the K1O4 is diffusing from the left end to the right end of the tube. Consider the collection of molecules to behave as dilute ideal gases and the difference in partial pressures in the two vessels causing the diffusion. So due to the difference in concentration of K1O4 in these two vessels, the partial pressure here and here is different. And this difference in pressures causes the K1O4 to diffuse from left to the right. So as pressure here is greater than here, the force on the K1O4 particles here is greater than here. So what happens is, due to this unbalanced force, these K1O4 particles start to move towards right. The speed V of the molecules is limited by the viscous force minus beta V on each molecule, where beta is a constant. So due to the difference in these forces, these molecules move towards right. And as they move towards right, there is a viscous force which acts on them, which is beta into V in the opposite direction. So the force due to the difference in pressures is balanced by this viscous force and these molecules move with constant speed. Neglecting all terms of the order delta n the whole square, which of the following is or are correct? Kb is the Boltzmann constant. So let us analyze the first option and see if it is right or wrong. The force causing the molecules to move across the tube is delta n Kb T into S. So we can say that this force here and this force here, the net of these two forces, which is unbalanced force, helps these to move towards right. So let us calculate each of these forces. He has mentioned that consider the collection of molecules to behave as dilute ideal gases. So using the ideal gas equation, we'll find the pressure here, and we can find the force once we find the pressure. And again, using the ideal gas equation, we'll find the pressure here, and we can also find this force. Let us use the molecular form of the ideal gas equation. So the molecular form is PV equals to NKT, where P is the pressure, V is the volume, N is the number of molecules, K is a Boltzmann constant, and T is the temperature. I am taking this V to the RHS, so we can write P equals to N by V into K into T. This N by V, we will write it as small n, where N is the number of molecules per unit volume. So N is the number of molecules per unit volume, which is nothing but the concentration. So the pressure here in this solution P1 will be equal to N1 into K into T. So N1 is the concentration here, so here the pressure will be N1K into T. The pressure in this solution the concentration is N2, so P2 will be equal to N2K into T. So the force due to this pressure will be pressure into area, so N1KT into S. The force here will be the pressure P2 into area, which is N2KT into S. The net unbalanced force is N1KT into S minus N2KT into S, which is delta N into, so this N1 minus N2 he has given as delta N, so delta N into KT into S. So this is the same value that he has given in option A, so option A is the correct option. The next option is force balance implies N1 beta V into L equals to delta N into KB into T. So he has mentioned in the question that the speed of these K-4 particles is limited due to the viscous force acting on them. The force due to the pressure difference is delta N KB into T into S. This force is balanced by a viscous force beta into V, which acts on each molecule of KMnO4. So the total viscous force which is acting on all the KMnO4 molecules here equals number of KMnO4 molecules in this region. So in this region, the number of KMnO4 molecules into beta into V. The number of KMnO4 molecules in this region is concentration times the volume. So concentration is N1 and the volume of this region is length into area. So N1 into L into S is the number of KMnO4 molecules in this region. So the total viscous force, the total viscous force is N1LS. So this number of KMnO4 molecules is N1LS into beta into V. So force balance implies the force due to pressure difference equals to the viscous force. We can cancel S and S both sides, so we get delta N KB into T equals to N1L into beta into V. So we can see in the option B, this is what he has given. So option B is a correct option. Let's move on to option C and option D. The total number of molecules going across the tube per second is delta N by L into KBT divided by beta into S. So let us consider this as a reference line, and in 1 second this molecule moves by a distance V. This length here is V meters. So all the molecules in this region, all the molecules in this region have crossed this cross-section area in 1 second. So we can say the number of molecules which are there in this region are the number of molecules going across the tube in 1 second. So the number of molecules in this region is concentration. The concentration is N1 times the volume of this region. The volume is length, which is V, into the cross-section area, which is S. So N1 into V into S is the total number of molecules which are in this region, and these are the number of molecules which are crossing the tube per second. The answer here is given in terms of delta N, Kb, T, beta and S. In option B, we had got delta N Kb T equals to N1 beta V into L. So in this expression, we'll put the value of N1 from here. So substituting N1 from here, we get this as delta N Kb T by beta L into S. We can see that this option matches with the answer that he has given. So option C is the correct option. In option D, he has given the rate of molecules getting transferred through the tube does not change with time. So the rate of molecules going across the tube is given as delta N, this Kb T by beta L into S is a constant. So it depends on delta N. As the molecules are moving from the left to the right, this delta N keeps on changing. It keeps on decreasing. So with time, the rate of transfer of molecules from left to right decreases. So he has given that it does not change with time. So option D is a wrong option.